Hello, welcome to the UTA 744 lab analysis of green crystals for cobalt content. You should have your green crystals made from the previous lab instances of green crystals. In this lab, you will use those crystals to determine their cobalt content using ion exchange and titration techniques. The lab has three parts: reduction, ion exchange, and titration. First, make sure you have goggles and gloves on. It is important to avoid any injuries while handling dangerous chemicals. You will first start by weighing out 0.7 to 0.8 grams of green crystals in a 50 milliliter beaker, and then weigh out 0.4 grams of zinc metal. You can then dissolve the crystals and the zinc in 20 milliliters of DI water and stir and swirl for 30 minutes. Record any changes in your lab notebook. After the 30 minutes have passed, you can decant the solution into a 50 milliliter volumetric flask. Make sure to not get any of the zinc metal in the flask. If there is additional residue left in the beaker, you can add 5 milliliters of DI water to wash it out. And then add enough DI water into the volumetric flask to reach the 50 milliliter point that I am pointing at. And now you can put a cap on the flask to mix it. You do not need to shake it aggressively to mix it. Instead, you can just flip it up and down. Now that you have your solution ready, you can transfer it into a 50 milliliter beaker. In this part, you will use an ion exchange column, which will already be set up for you by your TA. But make sure the resin stays wet throughout the lab. Dried resin is hard to clean up and will result in inaccurate results. Now you will pour DI water on top of the column and assess if the solution is acidic by placing blue litmus paper. If the paper turns red, then the solution is acidic. This indicates a presence of H+ ion and helps regenerate or recharge the resin. Now add DI water until the effluent runs neutral. To indicate if the effluent is neutral, you can check it with a blue litmus paper. If the litmus paper does not change color or remains neutral, as shown in the video right here, the effluent is neutral. This indicates that you're ready for the ion exchange with your solution. You can get 10 milliliters of your reduced solution into the column. Now drain the solution into a 250 milliliter Erlenmeyer flask until it reaches the top of the resin. You can pour 5 milliliters of DI water on the sides of the column to get any residues. And then keep pouring 10 milliliters of DI water over the column and keep checking if the effluent turns neutral. Once it turns neutral, that means the H+ ions have been exchanged. You will repeat this for run 2, but before that, you need to regenerate the resin. In order to regenerate the column, pour 50 milliliters of 3 molar hydrochloric acid and allow it to drain through the resin. Make sure you use a waste beaker to collect this effluent. Check the effluent to see if the solution is acidic by testing it with litmus paper. If it turns red, you have successfully regenerated your resin. The next part of this lab includes titration. There will be step-by-step instructions on your lab notebook about setting up a titrations, or you can go to your TA to ask questions. In order to give you an accurate result, make sure the burette is clean by rinsing it with DI water and then sodium hydroxide stock solution. Now add enough sodium hydroxide solution so the initial value is close to 0.1, since filling it up all the way will only lead to volume error. Make sure to record this initial volume reading in your lab notebook. And now you can place your run 1 solution under the burette. Make sure to add 2 to 3 drops of phenolphthalein to your solution. Add a stir bar into the solution and place it on top of a stir plate. You can let the sodium hydroxide drip into the solution. You will see pink coloration throughout. When it starts fading away slower, that indicates that your solution is close to the end. Let the sodium hydroxide solution drip until your solution in the Erlenmeyer turns pale pink. Your end solution should look like this. Make sure to record the final volume on the burette. And you can repeat this process for run 2. Now that you're done with the experiment, make sure to put all the waste solutions into the heavy metal container and make sure to clean all the instruments you've used in the experiment today. Thank you for watching. I hope this video has helped, and good luck with your experiment.